Let's consider you are working as a data analyst in a credit card company called Bank of Learnerea, wherein you have been given the annual transactional amount data for these 11 metro cities in India. Now your task is to summarize this transaction amount. Talk about this uh, transaction amount or maybe the credit card performance in a given year. So to summarize this, what is one thing and the first thing which comes into your mind? Of course, that's mean, isn't it? So when you find the mean of this transaction amount, you get it 6.09. And to summarize this transactional amount, you can say that in a year, the average transaction amount in each of these metro cities is 6.09 million. All right, but this is how you just summarize it. Just after this, your eye catch this particular number. If you see, this is just 3 million, wherein you are saying the average of transactional amount is 6.09, while this amount is just half of that, approximately half of that. So here it gives a very big difference. Then all of a sudden your eyes catch this another number which is just 2 million. So now, though you have summarized the data using mean, now you think of, is there a way that you could measure this variability or this spread of this data, this difference from the mean? Is there a way that you can measure this difference, how each of the data points are different from mean? And that's where you got the standard deviation. So as per Wikipedia, the definition for standard deviation is: the standard deviation is a measure of the amount of variation or dispersion of a set of values. So like we had the transactional amount for each of this city, so that was the set of value, and the differences from the mean which we are trying to get that will be called dispersion. To calculate the standard deviation, we usually take these steps. Let's have a look one by one. First, we will find the difference between mean and each of the data points, which will be the subtraction, and then we're gonna square that differences. We will see why we do that. Then we're gonna take average of the squared differences, right? And then we're gonna take the square root of this average. Let's try to apply this thing in our example. So here we had our transactional amount for each of this city, for which we calculated the mean is 6.09. Now the first step is, because we want to see how each of the transactional amount is varying from the mean. So what we're gonna do is we're gonna find the difference of each of these data point for each of this city from the given mean. All right, so that's the first step. Let's do that. Here, this is what we got. Now the problem is, because we have to give a summary, and now here we got just the difference from mean for each of the data point. Now how to summarize this? Okay, is there a way? So yeah, it's very simple. You can take the average of this, but to take average of this, you have to sum it up. Now if you sum it up, this might give you incorrect response, or maybe something which is not accurate, because you have minus, positive and negative both. So to fix this thing, we square each of the differences. We're gonna square this. Now you have all the numbers in positive. Now what you're gonna do is you're gonna take average of this squared differences. So that's the third step. Take average of this square difference. So if you take average of this square difference, that's gonna be 10.26. Now the next step is take a square root of this mean, which is 3.20, and that's called the standard deviation. So you can say the standard deviation is 3.20. Alright, so this is the formula to calculate the standard deviation. This is something which summarize all these 4 steps in one formula. So if you let's try to understand each of these elements. This is called mu. This particular symbol is called mu, right? So this represents to the population mean. In our case, that was 6.09, which we saw in the very beginning. Then this is called the this is the each of the data point in the population, means 3 million, 9 million, 10 million, etc. Each of these data point are represented by xi. This is what we did over here. If you see in this formula, here we are trying to subtract each of the data point from the mean, and then it comes n. So for us, n was 11, means how many cities were there, how many data points were there? There were 11 data points, right? And this is called the population standard deviation, right? So the standard deviation which we got is 3.20. This is usually called sigma, can also call it delta. What standard deviation we got is 3.20. Now let's go back to our old story. Here we had a mean of 6.09, and now because you have summarized it on mean, the other point which you want to add is 3.20. So when you are presenting, you can simply say that look, the average transaction amount in each of these metro cities is 6.09, but this has a dispersion or variability of 3.20, isn't it? So this gives the more meaning, this adds meaning to your first average. So in short, we can say that the standard deviation tells us the spread of data points around the mean value. I just hope that you understood this concept and you liked it. If you liked it, just give a thumbs up to it. And there are many applications of a standard deviation in data analytics. How effectively we can use this, I will tell you if you just tell me this thing in the comment section. You just give a thumbs up to this video and tell me in the comment section if you like this video, and if you want me to make another video on a standard deviation explaining how can we use this in our data analysis, what can it contribute to our data analysis. Till time, happy learning, enjoy learning, and all the best.